Okay, we'll get back to the notes here. We're on problem 26. We're talking about applications of quadratic equations. So again, these story problems here, every time I set up an equation representing the problem, it's going to be a quadratic equation. So just keep that in mind here. In problem 26, it says the base of a triangle is 5 inches more than its height. If the area of the triangle is 42 square inches, find the base and the height of the triangle. Okay, so I have this triangle. Here's the base and here's the height. Now the area of any triangle is always 1/2 base times height. Okay, so that's going to be just the general formula that I'm starting off with. The area of this triangle is 42 square inches. Okay, so 42 equals 1/2 base times the height. Now the base is 5 inches more than the height. Okay, so we don't know the base and we also don't know the height, but the base is going to be whatever the height is plus 5. Okay, so I'll go ahead and replace b with h plus 5, and then I have the equation 42 equals 1/2 times h plus 5 times h, and I need to solve this for h. Okay, here'd be my quadratic equation. So if I multiply both sides by 2, 42 times 2 is 84. That's equal to, if I distribute the h there into these two terms, h squared plus 5h. Okay, and let me subtract 84 from both sides. And now 84 has a lot of factors, right? So 1 times 84 is 84. 42 times 84 is 84, right? So now, if I'm not seeing how this factors right away, then I'm using the quadratic formula. Okay, so h is equal to the opposite of b is -5 plus or minus the square root of b squared. 5 squared is 25 minus 4 times a is 1 times c is -84, and this is all over 2a. 2 times 1 is 2. Okay, and then I simplify this so all my numbers are plugged in correctly. And so I got 25 minus a negative. That means I'm adding something to 25. 25 plus 4 times 84 would be 361. The square root of 361 is 19. Okay, so I got -5 plus 19 all over 2 and then -5 minus 19 all over 2. -5 plus 19 is 14. 14 divided by 2 is 7. And then -5 minus 19 is -24. And -24 divided by -2 is -12. H is the height of the triangle. The height of a triangle can't be a negative. That doesn't make any sense for what we have. Okay, so I'm going to throw away the -12 there. And it looks like the height of this triangle will be 7 inches. Okay, then the base is 5 more inches than the height, so 7 plus 5 is 12 inches. Okay, now because the h values ended up being these integer values here, like I could have factored this, it would have factored as h minus 7 times h plus 12 equals 0. I didn't see that right away though, and which is totally fine, so I'm using the quadratic formula, but I could have factored this is the point. Okay, let's try problem 27. So in problem 27, it says the length of a rectangular swimming pool is 2 meters more than twice its width. The pool is surrounded by a concrete deck that is 2 meters wide. if the area of the surface of the pool and the deck is 180 square meters, find the dimensions of the pool. Okay, so we got this rectangle and then this rectangular shaped pool. Okay, the deck is 2 meters wide in each of these directions here. Okay. Now, the area of a rectangle is length times width. The area of the big rectangle here is 180. Okay, so just the general formula that I'm going to be starting off with is area of a rectangle. Area equals length times width. The area of the big rectangle, again, is 180. So that's equal to the length times the width. Well, the length of the swimming pool is 2 meters more than twice the width. Okay, so we don't know the width. I'm calling that W. I also don't know the length, but I know that the length is 2 meters more than twice the width. So whatever the width is, if I double that and then add 2, I get the length. Okay, so let's see. Using the equation area equals length times width, the area of the big rectangle, again, is 180. Equals length times width. So the length of the big rectangle, well, the length of the pool is 2W plus 2. That's not what I'm asking for, though. I need to know the length of the big rectangle. Okay, so I got 2W plus 2, and then I'm adding 2 on the right and adding 2 on the left. So ultimately, I'm adding 4 to 2W plus 2. That'd be 2W plus 6. And then what's the width of the deck? Well, the width of the pool is W. That's not what I'm asking for. Okay, I need to know the width of the deck. So the width of the deck would be where I take the width of the pool, W, plus 2 meters up here, plus 2 meters down here. That'd be plus 4 meters that I'm adding to W. Okay, so W plus 4, that'd be the width of the deck. Okay. Area equals length times width. So this would be, you know, the kind of the start equation that I'd be using to solve. And if we FOIL this out, 2W times W is 2W squared. 8W plus 6W is 14W in the middle. And then 6 times 4 is 24 at the end. That's all equal to 180. Let's subtract 180 from both sides. So I got 2W squared plus 14W. 24 minus 180 would be negative 156. That's all equal to 0. Now, all three of these numbers are even numbers. So 2 would go into all three of them evenly, right? And if I divide both sides by 2, I'll have W squared plus half of 14 is 7. Yeah, 7W minus half of 156 is 78. That's all equal to 0. Okay, and here's my quadratic equation. Now this should factor. Okay, again, factoring is always the first thing that I'm going to think of here. So this should factor. It's going to be W times W, that's W squared. And then I need two numbers that multiply together to be 78, and then when I add them, I get 7. 13 and negative 6 are going to work. So 13 times negative 6, that's negative 78. And then 13 minus 6 is 7. Okay, so let me check this here. I got W times W is W squared. Negative 6W plus 13W, that'd be 7W in the middle. And then 13 times negative 6 is negative 78 at the end. That looks good. Okay, and again, if we're not seeing this, then we can't just do, we just can't do the problem? No. I'm using the quadratic formula then, right? So there's always going to be a way out if you don't see the factors, okay? Because not everyone's going to see this, right? So use the quadratic formula, and just give it a couple of seconds to see if it factors. If it factors, that's going to be the faster way to do this. If it does not factor, or if you don't see the factors, then you're using the quadratic formula. So w plus 13 equals 0. That means that w is negative 13. W minus 6 equals 0. That means that w is 6. W is the width of the pool. That can't be a negative. That doesn't make sense for what we have. So throw away the negative 13. It looks like the width of the pool is 6 meters. And then the length of the pool would be 2w plus 2. So 2 times 6 is 12. Plus 2 is 14. Okay, so the dimensions of the pool would be 6 meters by 14 meters. Okay. Let's take a look at so problem 28 is going to be a kind of a similar problem here. So problem 28, it says that a picture frame measures 12 centimeters by 20 centimeters. The frame has a uniform width on all 4 sides. So I'm going to call that width x. So the distance from the picture to the edge of the frame, we're calling that x on all 4 sides there. The picture inside the frame has an area of 84 square centimeters. Find the width of the frame. Okay, so by them giving me the area of this rectangle, this smaller rectangle here inside the picture, or the inside the picture frame, that suggests that I need to be working with the area of a rectangle. Okay, just as the general startup here. So area of any rectangle is length times width. The area of this rectangle is 84. So 84 equals length times the width. Okay, the length of the smaller rectangle, well, the length of the bigger rectangle would be 12, right? The picture frame measures 12 centimeters by 20 centimeters. So I'm going to take 12 and then subtract x and then subtract another x. So I'm subtracting 2x from 12. Okay, and that's going to give me the length of the picture. The width of the picture, well, the width of the frame is 20 centimeters. That's not what they're asking for, right? We need to know the width of the picture. So if I take 20 centimeters minus x up there, minus x down here, then 20 minus 2x, that would be the width of the picture. Okay, so this here would be the, kind of the setup equation that I would need to solve. And let me go ahead and FOIL out the right. 12 times 20 is 240. And then negative 24x minus 40x, that'd be minus 64x in the middle. Negative times negative is positive at the end. Right? So 2x times 2x, that'd be 4x squared at the end. And then when I arrange this, let's get everything under the right. I got 4x squared minus 64x, 240 minus 84, that would be 156. Okay, and that's all equal to 0. 4 is going to go into these numbers evenly. All 3 of these numbers are even numbers, right? So I can make the numbers a bit nicer than what they are. And again, look for those times where you can make the numbers nicer than what they are, right? Because it's very difficult to try to factor this guy right here, okay? Because 4, has more factors. 156 has a lot of factors, right? So if we divide both sides by 4, you got x squared minus 64 over 4 is 16, so minus 16x plus 156 divided by 4 is 39. That's all equal to 0. Okay, and here's the quadratic equation that we're working with now. This will factor. So if I use 13 and 3, 13 times 3 is 39. Okay, so it's going to be x and x. And both the terms are going to be a minus. sign, right? Because negative times negative is positive. Negative plus negative is negative in the middle. And then 13 times 3 is 39. So x times x is x squared. Negative 3x minus 13x, that'd be negative 16x in the middle. Negative 13 times negative 3, that's 39 at the end. Okay, so that's factored correctly there. And then if I set each factor equal to 0, x plus 13 equals 0 means that x is 13. X minus 3 equals 0 means that x is 3. Okay, now x is the width of the picture frame. That can only be one number. It's not going to be 13 centimeters, right? Because the entire length of the picture frame is 12 centimeters, right? So it's not possible to have x be some number that's bigger than 12. So throw away 13. That doesn't make sense for what we have. X is 3 centimeters. Okay, so the width of the frame would be 3 centimeters there. And that's the answer. All right, we'll go ahead and stop the video right here, and I'll pick up with problem 29 in the next one.